All right, this is the second video about the second partials test in 3 dimensions. Before we talked about how to find, we did some practice with the first derivative or second derivative test in 2 dimensions, and then we talked about how to find critical points for a 3 dimensional function. That is where both first partials are equal to 0 at the same time. So, in order to jump in to where we're going here, I wanted to restate the second derivative test in 2D. Because the second partials test in 3 dimensions is very, very similar in terms of its structure. It just has more complexity. So, what the second derivative test in 2D says is that if f prime of a, some x value, is equal to 0, and f double prime of a is positive, I always like to draw a concave up, then f has a relative minimum at x equals a. And the flip side, if f prime of a is 0 and f double prime is negative, draw a concave down, then f has a relative maximum at x equals a. So, the first step you do with these is you find the critical value, and then you find the partial, or sorry, you find the second derivative, and you plug it in, and you look at it. It's essentially the same idea with the second partials test, except for there's more pieces. So, second partials test. All right, so I guess I should just start by saying what it actually does. It finds relative min, relative max, and saddles for a multivariable input function. So for f of x comma y. You may say, what's a saddle? Well, let me draw one. The way we draw a saddle is I draw a parabola-y thing like this, and then I draw like this, and then like that, and then like that, and then I'll do one more that hits right there, and then I'm going to connect these guys, and I guess maybe I should have drawn this one. I'm going to erase this, whoops, and I'll connect it like this, so that that's the end, and then I'll connect these guys like that. What the saddle point is this one, like there's kind of like this parabolic shape opening up and this parabolic shape opening down, and they go in different directions. It's the same as a saddle point on in a mountain range, right? If you are familiar with driving through the mountains and driving over a pass, for example, driving over Loveland Pass or driving over Berthoud Pass, those have the general shape of a saddle. If you think about standing at the top of Loveland Pass, if you were driving from the east to the west, so towards Arapahoe Basin, you could look to your right and your left, and it would go up in either direction. You could look in front of you, it would go down. You could look behind you, it would go down. So that's what a saddle is. Hopefully that makes some sense. But what the second partials test does is it finds relative relative maximums, relative minimums, and saddle points. So, what do we do? First step, find CP. So the CP is a critical point. And this is where f of x, where f sub x of a comma b and f sub x of a comma b, this is a y, can't talk and think at the same time, are both equal to 0. So the first partials are both equal to 0. That means that a comma b is my CP. Okay, so then what I do is, and I can have multiple critical points, and I would just have to do what I'm doing here for all of the critical points. So step 2, we calculate a value that is usually referred to as D. Now, I think it should make sense to you that if I'm looking for a minimum or a maximum, that the first partial is supposed to have to be 0. It has to be flat in all directions in order to have a min or a max instantaneously. This next part, this determinant that I'm about to do, is not intuitive. But at a later time, I'm going to show you why this works. And it's actually super crazy cool, but I think it's better to just learn the mechanics of it and then go in and figure out why, right? So what is D? D is equal to a determinant. That's why we use D. And in the top left, I have the partial x, right? So f sub x, x of a comma b. And then in the next one, I have the mixed partials. So f sub x comma y of a comma b. And then in this corner down here, I have the mixed partials again. F sub x y of a comma b. And over here, I have f sub y of a comma b. Now, if you wanted to, you could take this guy and write it as yx. And then you could think about, all right, it's partial x, then partial x, partial y, then partial y, partial x, and then partial y. Kind of build a grid out, because the xy and the yx partials, the mixed partials, are always going to be the same. Anyway, I find this determinant. And I'm going to leave it like that. I will write it out. What would that be? Remember, determinant is this product multiplied by each other and positive, and then this product multiplied by each other and negative. So, what do we get? Remember, we did determinants when we did cross products. So it is f sub x of a comma b times f sub y of a comma b minus, because we do minus when we do that back derivative, or that back part of the determinant, f sub x y of a comma b. And then remember, they're the same thing, whether it's I go xy or yx. So I can just go like that and write squared. So that is D, whatever that is. And I'll show an example in a little bit if it's starting to get confusing. But there are 4 cases. So step 3 is we have 4 cases. And this part is like this, it's this secondary part of the second derivative test in 2D. So, first case, if D is positive, and actually for the second case, it is also if D is positive, right? So if D is greater than 0, and f sub x is also greater than 0. Oh, I should write f sub x of a comma b is also greater than 0. You can think about this, all right, as, all right, so this is the second partial, this is like a second derivative, right? That is like this piece right here in the second derivative test. Here, f double prime of my critical point, or my critical value, is positive. What's that give me? A min. Well, it's the same thing down here. Once we get that D greater than 0, if the second x partial is greater than 0, then what do we get? We get I'm going to draw concave up. We get, to make sure I don't mess it up, we get a min at f of a comma b. Now, you may say, well, why did you choose f sub xx? This f sub xx is actually totally replaceable with f sub yy. We could even write, or f sub yy. So, the second case, if D is greater than 0, and f sub xx of a comma b is less than 0, that would be negative. Let me draw concave down, right? Then what do we get on this f of x comma y? We get a max at f of A comma B. The D here being positive, what you can think about it as, and I'll show you why mathematically later, what you can think about it as is what it does is it ties all the second partials together. Whenever this determinant here is positive, it means that what the f sub xx does, the f sub yy also does that, right? So once I get d greater than 0, I can check one of the second partials and see if it's positive or negative. And I know that all the other second partials would be positive or negative, or sorry, would be that same like positiveness or negativeness. And I would get that min or that max, depending on what the value was. So since the D is what pulls or ties these things together, that D being positive, my third case is if D is less than 0. Now, what do you think that's going to be? Well, we had 3 cases up here. We got one of these two when D is greater than 0. Well, we're going to get this one right here when D is less than 0. So what it does is it determines that the second partials, the mixed partials are, or the second partials are not tied together. So what do we get? We don't have to check one of the second partial. We don't have to check a XX or YY. We get a saddle point at f of A comma B. And then you may say, wait, what's the fourth case? Well, notice greater than 0, less than 0. My fourth case is if D is equal to 0. And what do we get if D is equal to 0? This is the sad but true. We get no conclusion from the second partials test. It doesn't tell us anything about it. It could have a saddle, it could have a min, it could have a max. We don't know. This does not happen a lot, so you don't have to worry about that. And all the ones that I'm going to give you, well, maybe not all of it. It doesn't happen a lot. Hopefully you understand in general, and maybe I should write or f sub yy. I can look at either one. All right, so hopefully you sort of understand what this test is. I'm going to make one more video that has 2 examples in it, and you'll see how quick and easy it happens in some cases. So one more video, and that's it. All right, I'm back. I guess I should say that again, that you may be saying to yourself, I don't believe it. This D greater than 0, like I don't see why, right? And that's not the point of this right now. The point of this right now is for you to do some and get used to it, and then I will cover soon why this has to be true, because it is actually super crazy cool how much this comes up. And this structure of this determinant being positive or negative or whatever, or using this determinant, is something that comes up in math all the time.